Quadratic equations. A typical quadratic equation, and I've set up our screen here so we can see a couple of different things, but a typical generic quadratic equation looks like this. Ax squared plus bx plus c equals 0, where the a, the b, and the c, all they do is represent numbers. Our variables in this case are the x, and we have it set equal to 0. What makes something quadratic is looking at that middle term variable. And I'll try and highlight that here for you. This middle term variable, only the x, that's all I'm going to look at right now. If we can take that middle term variable and square it, and it gives us the first term variable squared, that's what makes something a quadratic equation. So for example, in this one, the x, if I square it, does give me x squared. Let me give you a couple of simple examples just to illustrate the point. Not that we'll be using a lot of these, but it helps to illustrate what we're talking about. Let's say I gave you one like this. 2x to the 6th power minus 3x to the 3rd power plus 5 equals 0. This is what we call a quadratic equation, because if we take our x to the 3rd power and we square it, I will get my x to the 6th. Let me demonstrate what I mean by that. If you take x to the 3rd power and you raise it to the 2nd power, you square it. One of our properties of exponents that we learned in Chapter 0 was that you would multiply these two variables together, which would give us x to the 6th power, which is exactly what our first term variable is. That's why this is what we would call a quadratic equation. Most of ours will look just like the original one that I have up here, and we'll do some examples of those here in just a second. Okay, with that, let's go back. Let's look at our first type of problem that we have up here. We're going to deal with something called the square root property. In solving an equation like this, we're going to try and keep it as simple as we possibly can. A problem like this, the easiest way to solve it is to use our wrap. Letters on the left, numbers on the right. Since there's only a 12 over here, I'm going to move that 12 over. It's going to become a positive 12. I'm going to do my like terms just like we've been working with. So I get my x squared equals a positive 12. Now, to solve this at this point, we use something called the square root property, which means I'm going to take the square root of both sides. Now, when I take the square root of the left-hand side, on this ledge right here, I call it, is what's called an index. That index, when there isn't one there, is assumed to be the number 2. And if this 2, let me write one in there, if this index and this power are the same, they essentially cancel each other off, so I'm left with just this number x equals, and then what I'd have is the number square root of 12. Well, that's a pretty good answer, except that what we should have learned, or what we should learn, is how to simplify a radical. See, what we have in here in this radical is we have what's called a perfect square. What do I mean by a perfect square? Well, if I made a little chart right here of x and x squared, if I took the number 1, 2, 3, and now over here I squared them, that'd be 1, that'd be 4, that'd be 9, and so forth and so on, and we can keep that pattern going. Notice that 4 is what we call a perfect square. What number is being squared to give you 4? The 2. Inside the number 12, we have what's called a perfect square. What number is that? The number 4. 4 goes into 12. So what I'd have to do to simplify this the correct way is I would have to rewrite this as the square root of 4 times 3, 4 being the perfect square. And then I could break those up. We have a property of radicals that says those can be broken up individually. And what is the square root of 4? 2. What's the square root of 3? Well, I don't know of one. There's no number up here that would go into the square root, would go into 3. Therefore, it doesn't have one, so I just leave it inside. And so my answer turns out to be x equals 2 times the square root of 3. All right, let's look at some more. Now, something else, let's backtrack just for 1 second here. Whenever we take a square root, remember what I'm really asking for is, and I'll use an example over here, if I say something like the square root of 36, what I'm really asking for is what number, when I square it, will take me back to that 36? Well, most people would say, well, that's 6. Well, you're absolutely right. However, wouldn't negative 6 also work? Because isn't a negative times a negative, wouldn't that take us back to 36? So when we take square roots, we actually end up with what we like to term in the math world as plus or minus 6. Because plus or minus 6 would actually take us back to that 36. So in our answer over here, what I want to include is I'd want to include the plus or the minus in front to show that we could have both of those values. Okay? All right, now, let's take another quadratic type equation. Let's use one like this. Some of them aren't quite as simple as what we just stated. If I had 2x squared minus 9x minus 35 equals 0. Unfortunately, in this case, we can't just use that square root property. We can't just bump something over, take the square root of both sides, and be done. It doesn't work that way in this particular case because I have an extra x in here. But I do have a quadratic. So what we have are a situation where I have 3 options that we're going to learn for solving quadratic equations. Our first option is going to be by using a method called factoring. We're going to factor both sides. So I have the option of being able to factor it. The second method we're going to learn is something called, and I'm using an abbreviation, completing the square. You'll find sometimes I like to shortcut because I don't want to write it out too much for you because then it just gets overdrawn, so we'll leave it like that. And then the third one is what we call the quadratic formula. Now you may have recognized some of these terms, but I'll walk you through how we do each one of these. Well, here's what we're going to do to start with. We're going to try and solve the first one by the method called factoring. When I factor, I like to look at things from a smile perspective, and that is this. Since I can't just move something over and solve it, like we did in one of our previous videos, I'll set it up and go, all right, if it factors, that means that I'm taking something times something, and it's going to take me back to that original problem. In this particular case, I need to figure out, and I'm going to start with just looking at the 2x squared. What two numbers multiply to give me 2x squared? Well, the only thing that I know of is 2x times x. Now, some would say, well, why can't you put an x squared, like a 2 on one side and the x squared on the other side? Well, we want to separate out our x's so we can solve this. We want to get down to where x equals. Our ultimate goal is to get this thing down to the point where it goes x equals, and then we have our answers. So that's why we're putting 2 separate x's out here. The next thing I'm going to concentrate on is just the negative 35. I'm not going to look at anything else right now. I'm just going to look at this piece right here. That's the second thing I'll look at, the negative 35. What numbers multiply to give me negative 35? And at the same time, I'm kind of keeping that 9 involved, and I got this. Well, here's what I know. It's a negative. I know that one of these has to be positive and one has to be negative. Do I know which one is which? No, not yet I don't. But I'll just put them down. So let's say this is the positive. We'll say that this is the negative. Trying to think of numbers that multiply to 35. You know, off the top of my head, the only ones that really jump out at me are 1 times 35 and 5 times 7. Well, 1 and 35, boy, they seem awfully big if I plug them in here. So I don't know for sure that they're going to work. So I'm going to try the 5 and the 7. Now, this is not a guess and check because I know for sure I've got my negative 35. It's just, did I put them in the right spot? How do we know that? I'll show you how we get that in just a second. So let's go ahead and look at this. I tell you what, I'm going to go just in the order that I have them written. I'm going to plug the 5 in here. I'm going to plug the 7 in here. Here's what I do know. I know that if I take 2x times x, I get 2x squared. I know that if I take 5 times negative 7, I get negative 35. I know we're in pretty good shape from that standpoint. How do I know for sure I got the negative 9x? Well, I'm going to do this on my marker board here so you can see this real quick. If I take 5 times x, I get a positive 5x. That's my little smile. Big smile because I'm almost done. 2x times 7 gives me a negative 14x. And when I add those two together, lo and behold, there's my negative 9x. I now know that I have factored this correctly. So now I know that it's factored correctly. Let me clean this up a little bit for us so we can move on and keep moving with this. Once I get it factored, now my goal is to take each of the factors, this factor and this factor, I'm going to set them equal to 0. So I have a 2x plus 5 equals 0. I like to draw a line down so I keep them separate. And I have an x minus 7 equals 0. Well, with that, now let's go ahead and go and solve this. I'm going to wrap this 5 over using my wrap like we have done before. So I got my 5, I take it over. So that's going to leave me with, put it over there, negative 5. So I end up with 2x equals negative 5. If I divide both sides by the 2, I end up with my x equals a negative 5 halves. Try and make my screen a little bit bigger here for you to see. There's one of my answers. On the other side, well, this one's much easier for me to look at. If I take that 7 and wrap it over, it's going to become a positive 7. So now when I set this up, I end up with x equals a positive 7, and there's my other solution. So my two solutions for this particular problem, x equals a negative 5 halves, x equals 7, and that's how we solve quadratic equations, either by factoring or by using that square root method that we looked at before.